Hello everybody and welcome back to question number 20 now on the Fermat paper. A soccer ball rolls at 5 meters per second towards Marcos in a direct line from Michael. That's not going to get confusing. The ball is 15 meters ahead of Michael, who is chasing at 9 meters per second. Marcos is 30 meters away from the ball and is running toward it at 8 meters per second. The distance between Michael and Marcos, when the ball is touched for the first time by one of them, we don't know who, is closest to. Okay, so just like the last question, and I think another question a little while ago, I think another question at least that I've recorded today, they've got this is closest to. So last time it was to the nearest tenth, but this immediately makes me think I should be grabbing my calculator. Okay. Now, if memory serves, because I recorded the Kaylee before this one, I think the Kaylee has this question on it as well, although it's not question 20, it's like 25 or 24 or something like that. And this does happen every once in a while, that they take a question from, say, the Pascal, a really hard one there, becomes a somewhat harder one on, or a somewhat hard question on the Kaylee, and then, you know, a not too hard one on the Fermat. This happens every once in a while. It's rare for a question to go Pascal, Kaylee, and Fermat. Usually you'll get like 25 on the Kaylee becomes 21 on the Fermat, or 23 on the Pascal becomes 16 on the Kaylee, that sort of thing. In recent years they've been trying to stop that from happening, but you know, every once in a while you just don't have enough good questions, so you nick some from another competition. Okay, but as I was trying to say, I believe on the Kaylee, if I remember, this was a couple weeks ago I recorded the Kaylee, this question actually does come out to be exact. And I want to say it's 2.50 meters. I think that's the right one. So it's C, but we're going to find out because I do not remember. Okay. So placing my bet now that it's C, just whether or not my memory from a couple weeks ago is that good. Alright, so they've drawn a nice little picture here for us, and that's great. The ball is moving, Michael's moving, Marcos is moving in a direction opposite to the two of them. Now, we want to know the distance between Michael and Marcos when the ball is touched for the first time by one of them. I think the first sort of intermediate thing to do would be figure out who touches the ball first. So Michael is sort of chasing after the ball. So the question is, how much is he gaining on the ball? Is he going to overtake the ball in time? Right? So the ball is rolling away from him at 4 meters per second, but he's chasing after it at 9 meters per second. So every second he's gaining 5 meters. 9 meters per second minus 4 meters per second is 5 meters per second that the difference between Michael and the ball is shrinking. Okay? So can he overtake the ball in time? And now Marcos is approaching the ball, and the ball's approaching him. So it's sort of like there's Marcos is getting sort of a boost because the ball is trying to get to him as well. And Marcos he's running 8 meters, but the ball is coming at him 4 meters. So overall, the change between the two of them is 12 meters per second. Marcos is getting closer to the ball by 12 meters every second. And so can he and the ball meet before Michael overtakes the ball? That's sort of the idea. And because we know the distances between Michael and the ball and Marcos and the ball, we can set up some equations to work this out, because distance divided by speed is equal to time. So we'll be able to figure out in how much time does Michael need to cover the 15 meters between him and the ball? How much time does Marcos need to cover the 30 meters between him and the ball? That's the idea. So, what we can do is we can write some of this down. It's almost as though it's sort of like something you might see in a physics class. Imagine the ball is the fixed reference point. From the ball's perspective, how fast is Michael gaining? So Michael is covering the distance to the ball at a speed of, he's moving at 9 meters per second, but the ball's going away 4 meters per second, so a total of 5 meters per second. So imagine we were just sort of sitting on the ball, we'd see Michael approaching, and we would measure his speed away from us at 5 meters per second. Okay? Marcos is covering the distance at a speed of, he's moving at 8 meters per second, and the ball is helping because the ball is approaching. But if we imagined the ball was fixed, if we were sitting on the ball, it wouldn't feel like we're moving, but it would look like Marcos is getting closer to us, not at 8 meters per second, but at 12 meters per second. Okay? So, I always try and remember it like a triangle. Distance, speed, and time. You sort of fill it out alphabetically. But the point is, if I want to know how long, the time does it take to cover a certain distance, I cover up the time and I get distance over speed. So time. And if I wanted speed, I could cover up speed and I'd get distance over time. If I wanted distance, it would be speed times time. The point is, it takes Michael, he's got to go 15 meters, and he's going at 5 meters per second. You know you've set this up properly when the units cancel out and the over seconds moves into seconds on the top. 15 over 5. It takes Michael 3 seconds to reach the ball. Okay. Does Marcos do better or does Michael do better? It takes Marcos, so he's got 30 meters to cover at 12 meters per second. The seconds will go up here, and then 30 and 12 is a factor of 6 there, so 5 over 2, 2.5. Well, there's the 2.5. So maybe my prediction was wrong, but I was remembering an appropriate number. So it takes Marcos 2.5 seconds to reach the ball. Marcos gets there first after 2.5 seconds. Okay. That isn't the answer, though. That's just who reaches the ball first and at what time. Marcos gets there. The time is 2.5 seconds after we've started. Okay, so we could draw a little picture representing what has happened almost. So we started out with something like this. Michael here, the ball here, and Marcos over here. And there's 15 meters, and then 30 meters. And then 2.5 seconds later, the ball is maybe over here. Marcos has caught up to the ball. And Michael has covered some distance as well. And the question is, what is this distance? Okay, what is the distance between Michael and now the Marcos ball hybrid? Because essentially the ball and Marcos are at the same place. So what distance is left? Well, it's going to be something less than 15 meters because Michael's been covering that amount. So how far? How much of the 15 meters has Michael covered in 2.5 seconds? So he has covered, well, this is, we know the time, we know the speed he's at. So he covers, not this D, but he has covered speed of 5 meters per second, and he did it 2.5 seconds. So the seconds cancel out, we'll be left with meters. 5 times 2.5, that's like 5 times 25, which is 125. We'll just move the decimal place. 12.5 meters. So he was 15 meters apart. After 2.5 seconds, he's covered 12.5 meters. So he still has 15 meters minus the 12.5 that he managed to make up, 2.5 meters to go to get to the ball. Since Marcos is at the ball, this is now the distance between Michael and Marcos, as well as the distance between Michael and the ball. I guess the reason they have the to the closest meter, because we got it bang on, 2.5 meters, which incidentally is the C that I predicted. But I guess the reason they did that is because the ball isn't of infinite width or something like that. And so one could argue that, yeah, between Michael and the ball is 2.5 meters, but then between Michael and Marcos is 2.5 meters plus the, I don't know, foot that the ball is. So, yeah, they didn't make it that complex, right? They didn't give us the speed of a ball. No, they're not the speed of a ball, but the diameter of the ball. So we're fine. And the answer is C, 2.5 meters. Okay. So I'll just underline him, and this is C. Okay. So that's question 20. And then we get in next video, we're going to be starting question 21, and we are in there with the big boys, the hard questions, the last 5. We'll see what we can do. Quite interested to see what's going on with this cube and this cone here. But we'll save that for another video. And if you guys haven't already, please at least try the questions in Part C to see where your weaknesses are. Can you do question 21 no difficulty? Do you have problems with the geometry question that is 25? These are the important things for you to find out if you want to do well on the contest. Identifying your strengths and weaknesses is great. Okay? So I'll see you guys for question 21 in the next video. All right? So long.